Hello dear students, very good evening to all of you and welcome to BYJU'S Exam Prep. So guys, here is your next session of structure analysis in which we will discuss the displacement method. And you know that guys, in the GATE examination, mostly you will get the question from the displacement method like your moment distribution method, slope deflection method and stiffness matrix method. So today we will discuss the problem which is related to this particular topic, and I hope all of you are able to understand the concept. I will tell you about that concepts also, whatever concepts are required, as well as guys, we'll discuss the solution in detail. Okay. So kindly share this session to other students also so that everyone can join the session and they will get benefit of it. Okay. So let's start this session guys. Let's start this session. So I think some of you may be possible guys, some of you are new over here. So let me introduce myself. My name is Krishna Yadav and I'm teaching from last 9 years. And generally these are the subjects in which I deal, basically structure, environment, RCC and mechanics. Okay. Guys, there is one more information which I want to give you over here. There is basically a free GATE Achiever series which is going on our app. So what you can do guys, you can register on the app and ultimately you will able to access this particular series also. Okay. There is one more session guys which is mega workshop. If you want to give your GATE examination in 2024, so you can attend this particular session on 25th of September, right? So let's start the session guys with question number 1. This is our question number 1. Please tell me the answer of this question guys. What will be the answer for this particular problem? Just you have to solve this question and at the same time I'm also solving and we will discuss the problem in detail. Okay. This is basically MCQ type of question. And what is given in the problem, let's understand first. A propped cantilever is there guys whose span length is L and it is subjected to a point load which is basically P at the support itself, right? At this particular support a load is present, right? Now what will be the bending moment of end B? Now you need to tell me what is the value of bending moment at end B. That is the question guys. Okay, tell me the answer guys quickly. What is the value of bending moment at support B when we are applying a load which is basically P at support A? That is the question guys. Tell me how much it is. Little bit tricky question, but guys, you can solve it. It is very simple. Okay, so the answer is basically what? 0. Why it is 0? Let me explain it. You know that guys, at this particular support, the same amount of reaction can be generated, right? The value of support reaction is equal to how much? It should be P. Now tell me guys, if you find the moment at this particular end, which is B, so definitely it will be equal to how much? It is equal to 0. Why? Because if you take the summation of moment at B is equal to 0, ultimately you are able to get this particular MB is equal to 0 also. So let me write here guys. We can write here summation moment at B is equal to 0. So P into L minus P into L and plus MB and which is equal to 0. Now this MB value is nothing as it is 0 basically, right? So that's why C is the correct answer for the problem. Let's move to the next question which is in front of you. Now you need to choose the correct option with respect to the displacement method. Okay. Tell me guys. Following methods are used for the analysis a structure problem, right? Method of consistency deformation, slope deflection method, stiffness method and flexibility method. Now tell me guys, out of these 4 options, which of the following option can be correct as per the displacement method? That is the problem. Method of consistent deformation, it is basically a force method. This method is what? It is basically force method. If we talk about slope deflection method, it is a displacement method in which we are having certain displacement values which is unknown to us, right? This is displacement method. Stiffness method is also a displacement method, right? It is also a displacement method. But if we talk about flexibility matrix method or flexibility method, this is basically the force method. Now only 2 methods are there, which is basically the displacement method, second and third. So that's why guys, B is the correct answer for the problem. B is the correct answer. Okay. Let's move to the next question, which is MCQ type problem guys. Next question in front of you. Next question in front of you. Next question. There are basically three members AB, BC and BD, which is connected at a joint B. This is basically our joint B, right, where all three members are connected, right? A is basically fixed and the remaining two supports are hinge. Okay, now the length of member AB is L and BC is equal to 1.5 L. BC is equal to 1.5 L and AB is equal to L, and BD is equal to 2.5 L. This value is given to us, which is 2.5 L. Now what is the distribution factor? What is the distribution factor of member BA at B? That is the question. We need to find out the distribution factor for BA member. Now it is very simple. First you need to find out the stiffness of each and every member. What is the stiffness of member AB? What is the stiffness of member AB? Can I write here, guys? The far end is fixed, so we can write here it is 4EI by L. Similarly, what is the stiffness for BC member? It is equal to 3EI by L. Similarly, what is the stiffness for BD member? It is also 3EI by L. 3EI by L. Now guys, you need to see here the value of length of each and every member are different. Now AB is what? L. What is BC? BC is 1.5 L. We need to put 1.5 times of L over here. Now BD is 2.5 L. That means we need to write 3EI divided by 2.5 times of L. Okay. Now what we need to do, guys? Basically we need to find out the distribution factor for BA. Okay. So can we write here distribution factor for BA is equal to stiffness of BA divided by summation of all stiffness. Summation of all stiffness. So let's put the value. What is the stiffness of BA member or AB member? It is basically 4EI by L. Okay. Now divided by addition of all three values. So let's add all the values first. 4 plus, then we have 3 divided by 2.5. Okay. So this value is coming around 7.2, right? So 7.2 EI divided by L. Okay. So let's calculate, guys. 4 divided by 7.2, how much we are getting? It is coming around 0.55 something, right? It is coming around 0.55 something. That means it is around 0.56. That's why A is the correct answer for the problem. A is the correct answer for the problem. Clear? Let's move to the next question. Let's move to the next question. A propped cantilever is given below. Find out the value of theta B. Our task is, due to given load, we need to find out the value of theta B. Now, as per the question, you need to use the slope deflection method. Either you can use the slope deflection method, you can use moment distribution method, that is your wish, right? But guys, this is the question which is given to us, right? Now tell me, in case of slope deflection method, what we have to do basically, first we need to find out the fixed end moments of joint A and joint B due to given loading, correct? Okay, so let's fix all the support first. Let's fix all the support. This end is fixed and this end is also fixed. Let us consider a UDL is present on the entire span whose intensity is W, okay, and the value is given to us, which is 25 kilonewton per meter. Clear? Now guys, what is the value of end moment? We need to calculate it first. So this is basically MAB bar, which is equal to minus WL square by 12, and this value is MBA bar, which is plus WL square by 12. Clear? Now let's put the value first. So it is equal to 25 and the span length is given to us, which is 8. So 8 square divided by 12. Let's calculate this value first. How much it is? 25 into 8 square divided by 12. So we are getting a value of minus 133.33 kilonewton meter. Similarly, guys, this value will be same, but the sign will be opposite, which is 133.33 kilonewton meter. Clear? Now what is the slope deflection equation for member AB but at joint B? We need to write at joint B first. Okay, so do you know guys how to write it? It is MBA is equal to MBA bar plus 2EI by L into 2 theta B plus theta A minus 3 delta by L. Correct? Okay. Now tell me guys, if your end A is fixed, then what is the value of theta A? It is equal to 0. What is the value of theta A? It is equal to 0, right? This value should be equal to 0. Now if we talk about this particular support or this particular support, it will not settle down. So definitely the delta value is also 0. Okay. Now what about the overall moment? Overall moment at joint B, it is equal to 0. Why? Because this particular support is a hinge support. That is the reason. So this particular value you need to make 0 again. Now what is the value of MBA? MBA is equal to plus 133.33 plus 4EI into theta B divided by L. L is what? 8. And it should be equal to 0. Now what is the value of theta B? Can we calculate it easily? Minus 133.33 multiply by 8 divided by 4EI. Okay. Let's calculate guys how much we are getting. Please let me know. So we are getting a value of minus 266.66 divided by EI. So this is nothing as this is the value of theta B which we are getting over here, right? So theta B is equal to minus 266.66 divided by EI. That's why A is the correct answer for the question number 4. Clear? I hope all of you are able to understand the question very well. Clear? Okay. So let's move to the next question guys. Let's move to the next question which is in front of you. Kindly see this particular problem and let me know the answer. Again, this is MCQ type question. Suppose a moment of 2000 kilonewton per meter is applied at joint A. The value of moment MAB is dash kilonewton per meter. Our task is to find out the value of MAB over here, right? That is the question. So what we can do guys, basically, first we need to find out the value of distribution factor at support A for AB member. Okay. So again, we need to find out the distribution factor. How we can find it out? Distribution factor for AB is equal to what? KAB divided by summation K. Okay. Now what is the value of KAB over here guys? It is 4EI by L, right? So we can write here, it is already 4 over here, right? So you need to multiply it by your factor also. That means 4 into 4EI by L. Okay. 4 into 4EI by L. L is equal to how much? It is L only. Now divided by summation of stiffness. What is the stiffness for this member? It is 4EI by L. This one 4 into 4EI by L. This one 4 into 5EI by L. Okay. So let's find out what is the value of distribution factor first. Let's find out what is the distribution factor over here. 16 divided by 4. So we are getting a value of 2 by 5 as a distribution factor for AB member. Now the question is we need to find out the moment value for AB. Okay. So can we write here guys, MAB is equal to what? It is nothing as, it is distribution factor of AB multiplied by the moment which is applied at this particular joint. So it is 2 by 5 multiplied by M. M is equal to how much? It is 2000. Okay. Kindly calculate it. How much we are getting? 800. So 800 kilonewton meter is the answer. 800 kilonewton meter is the answer. Crystal clear? Crystal clear to all of you guys? Okay. Very nice. Let's move to the next question, which is a numerical answer type problem, and it is related to the slope deflection method. Okay. Now guys, what is given in the problem? Let's understand first, then we will solve it. A rigid frame ABCD has AB member as a overhang with end A being free. Supports C and D are fixed. Okay. So we need to draw the figure first. Okay. Let us suppose ABCD is our frame. Okay, ABCD has a frame, AB as a overhang with and A is being free and C and D. Okay, AB is overhang. Let's draw it. Let us suppose this is A. This is A, which is free end. Okay, and this is B. Now BC is horizontal member and BD is vertical member. BD is vertical member. Okay, I think we have to remove this, right? It is not required. Okay. Now guys, support C and support D are fixed. So you need to make this support as a fixed and this one is also fixed. Okay. Now DB is vertical member. Yes, it is perfect. Vertical member, and BC is a horizontal one. Yes. DB value or the span of DB is 5 meter and the BC is also 5 meter. Now the moment equation is already given to us for DB portion, for BD portion, BA portion, BC portion and CB portion. Now the question is, what is the value of theta B? We need to find it out. So guys, tell me, if you know the moment value at this particular joint for different member like BA value, BC value and BD value, if I take the summation of moment at this particular joint which is equal to 0, that can be true, right? So can we write here guys, this is our MBA, this one is MBD and this one is MBC. Okay, we need to take the summation of all these moment is equal to 0, then we'll get our answer. So can I write here guys, summation moment at joint B is equal to 0 and minus of MBC minus of MBA and minus of MBD is equal to 0. Now what is the value of BC? BC, 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 BC. BC is 0 or something else? No, BC cannot be 0. BC is equal to minus, first we need to write minus, the value is minus 135 plus 1.6 EI into theta B. Then minus BA, BA is equal to how much? It is already given, which is 54. Then BD is equal to how much? BD is 0.8 EI theta B and it should be equal to 0. Clear? Now our task is to find out the theta B value. Okay, let's do it guys. So this value will become 135 positive minus 1.6 EI theta B, then minus 54 minus 0.8 EI theta B and it should be equal to 0. Okay, let's find out guys what is the value of theta B. 135 minus 54, 81 divided by so what we are getting as an answer, let me write here guys, theta B which we are getting over here after solving this equation, how much we are getting? 33.75 divided by EI and the value which we are getting is a positive one. Okay, so this will be our rotation, this will be our rotation, right? So how much we are getting? 33.75 divided by EI. 33.75 divided by EI. This is the answer. Clear? Let's move to the next question. Now you need to tell me guys how many point of inflection you may get in this particular portal frame, right? Now what is point of inflection? It is the location where the curvature of elastic curve will change, right? And the point of inflection and the point of contraflexure both are having same significance, but they should be plotted on different diagram. Your point of inflection should be plotted on the elastic curve and the point of contraflexure should be plotted on the bending moment diagram, right? Now, please tell me guys, if you draw the BMD or if you draw the deflected shape of the structure, you are able to understand how many point of inflection should be there. Kindly draw the deflected shape of the structure. It should be like this, right? The deflected shape of the structure should be like this. Now you can observe over here guys, basically there are 4 points where the curvature is trying to change. First one is this one, second is this one, third is this one, and fourth is this one. So total 4 points are there where the curvature is trying to change. What do you mean by curvature? Basically this curvature is what? Concave. What is this curvature? It is convex. Sorry, it is convex and this one is concave. It is convex and this one is concave, right? Now you can see here guys, this point at which the curvature is trying to change is nothing as point of inflection. So total 4 points are there. That means these are 4 points of inflection. At the same point, you may get the point of contraflexure also in the structure. Next question in front of you guys. Next question in front of you. Tell me the answer of this one. Next question in front of you, which is again MCQ type of problem. Next question in front of you. Due to settlement of support A, of probed cantilever shown in the figure given below, what is the vertical reaction at B? That is the problem. Now let us suppose guys, this particular support A of the probed cantilever will settle down, okay, like this. This support is settled, okay. Now you can observe guys, at this particular end we are having only one reaction, which is to be like this, okay, and this is the amount of settlement, which is basically delta, correct? Now tell me guys, what is the value of moment which will come over here? What is the value of moment which will come over here? You know that guys, at this particular end, the moment is equal to what? 0, because this end is a hinge one or a roller one. Now you can see here the direction of settlement is like this. The direction of settlement is like this. So the moment should be generated in this way. And this value is equal to how much? It is equal to 3EI delta by L square. Now guys, let us suppose this point B, at point B we can make the summation of moment is equal to 0. And our task is to find out the VB value. Okay. So what we can do guys, let's make the moment, summation moment at A is equal to 0. Then it will be better. Okay. So let's make summation moment at A is equal to 0. So minus of VB multiplied by L plus 3EI delta by L square, and it should be equal to 0. So VB is equal to how much? If you solve it, you will get 3EI delta by L cube. So which one is the correct answer? D as a correct answer for the problem. Correct? D is the correct answer. Next question guys in front of you, which is related to the you can say that sway condition. You need to understand in which direction the sway can occur. That is the problem which is given to us. Okay, and it is a MSQ type question. Be careful while reading the statement first. Okay. Now kindly check this particular question guys. If the flexure rigidity of beam BC of the portal frame is given in the figure is assumed to be 0, right? This particular flexure rigidity of the beam is equal to 0, right? This is equal to 0. The horizontal displacement of beam would be, tell me guys, kindly read the statement. Okay, kindly read the statement. Kindly read the statement quickly. Please check the statement first, then we will discuss the question guys once again. Okay, I'm checking what is missing in that particular statement. Just a second. Okay, I need to check what is missing in that statement. Okay, no issue, let it be. I think that statement is means some point is missing in that statement. Okay, the horizontal displacement would be I don't know what is it written over here. I think, okay, no problem. Let it be. let's remove this particular statement. Let's check the other one. The frame will sway in the rightward direction. First, we need to understand whether the sway will occur over here, whether it is in rightward direction or leftward direction. Now you can see here guys, due to this particular load, which is basically P, which you are trying to apply in this direction, so definitely your whole structure is trying to shift in the rightward direction only, right? So that's why B is the correct answer, right? It is trying to sway in the rightward direction. Now guys, if the height of both the column is increased by 2 times, if you increase the height of column, which is basically this one H, then the horizontal displacement is increased by 8 times. Now listen guys, do you know that if you try to apply force like this, then this particular member is trying to deviate in this manner. Now what is this displacement value? Do you know that? It is 6EI delta by L square in general, correct? Now the question is, if you increase the height of column by 2 times, that means we are trying to change this particular L value or H value. So if you increase this particular H value, let us suppose if we increase by 2 times, okay? So 2L whole square, okay? What we can do, let's make it simple so that everyone can understand, okay? Let's make it simple. I will analyze it directly, you will understand it. Now basically this is the deflected shape of the structure. Now tell me guys, this value is what? Delta, okay? This value is also delta, okay? Now guys, listen carefully. You know that due to this particular delta, we are having certain value of displacement, certain value of moment over here, like this, and the value is 6EI delta by L square. Similarly 6EI delta by L square, and this value is 6EI delta by L square. Similarly this value is 6EI delta by L square. Now the question is, tell me guys, when you are having EI is equal to 0, listen very carefully, then only you can understand this particular point. When you are having EI is equal to 0, what it means actually, let me show you that with respect to our equation. M by I is equal to E by R is equal to sigma by Y, okay? Now guys, you can see here, if I write here EI by R, EI by R, or yes, EI by R is equal to what? M, right? So tell me guys, in this particular case, if value of EI is equal to 0, then this particular beam is not capable to take any kind of movement, right? It will not capable to take any kind of movement. So what will happen basically over here? This particular end and this particular end will act as a free end. It will act as a free end. It will act as a free end. Okay, it will act as a free end. If it is free end, then what will happen, sir? Let me explain. If it is free end, then what will happen? Let me explain it. Let us suppose this is a cantilever beam, and if it is acting as a free end, then this should be the deflected shape. Okay, and let us consider certain force you have applied over here. Let us suppose F. Okay, now this is our length L. Now tell me guys, how much moment will generated at this particular end? Can I say that it is equal to F into L only? Yes or no? Tell me guys. This particular moment is equal to what? F into L only. Yes or no? Please let me know guys. If it is a free end, then only this particular moment can be applicable, which is F into L. Okay. Now you can see here guys, what is the value of delta that we need to find? What is the value of delta that we need to find in this case? Anyone who can tell me guys, when you have a free end, then what is the value of delta in this case? It is equal to what? FL cube by 3I. FL cube by 3EI. Simple, simple. Now kindly see this particular example guys, then you will understand it. I am removing this particular drawing. Okay. Now tell me guys, if this particular end is free end, this end is also free end, and you are having a delta value which is FL cube by 3I. Now tell me guys, what will happen in this case? If you increase the height of the column by 2 times, the horizontal displacement will increase by 8 times. Yes, it is so. Why? Because you can see here guys, this value of delta is depending upon length of the column, right? So if I increase this particular value by 2 times, that means F upon 3EI 2L cube. So it will become 8 times FL cube divided by 3EI. So this is nothing as, this is our delta value. Yes or no? This is our delta value, initial delta value, correct? Now, can I say that guys, this statement is correct? This statement is correct. This statement is also correct. This is wrong because something is missing over here guys, and I think that value is not mentioned in the question right now. So let it be this particular option. Okay, you can cancel this option easily. Now let's understand the next one. If the EI value of beam BC is infinity, then okay, I think there is something missing in this particular question guys. Let's remove this particular statement also. You can understand these two statements are correct. I think there is certain value which is written over here, but it is not mentioned in the question. So let it be right now. But guys, you can understand these two statements, how we can solve it. Okay, let's move to the next question. This question I am giving as a homework guys. Please solve it by yourself. This is basically a homework question for you, which you can solve. And this is again MSQ type of question. Okay. Now let's solve the last one guys. Last question in front of you. If all the restraint are removed, which is present at support C, then the flexure stiffness will. Now listen guys. Whatever restraint which is present at this support C, if we remove it, then the flexure stiffness will get changed or it will remain same for member BC. That you need to tell me guys. For member BC, sorry, member OC, what will happen guys? Whether this particular stiffness of the member will change or it will remain same. That is the question. Flexure stiffness. Flexure stiffness means what? Like if you have this particular support condition, see, Vikas, see, there is no change. Okay, Vikas. Why? Why there is no change? Tell me guys, if you have a fixed support like this, okay, if you have a fixed support and let us suppose this one is hinge. So what will happen guys in this particular case, on the support itself, Rajesh B. Okay. Guys, listen, first of all, you need to understand this value. Okay. Listen. First of all, tell me guys, what is the stiffness in this particular case? Can I say that it is equal to 4 EI by L when we have far end as a fixed, right? But tell me guys, in this particular case, when you are having far end as a guided roller, okay, far end as a guided roller, you may have the stiffness also. But if you make it free or if you remove this particular restraint, then this particular end will become free. And whenever we are having a free end, then tell me guys, in that particular case, the stiffness is always equal to how much? It is equal to 0, right? But when we have a guided roller support over here, then you know that guys, certain value of stiffness should be there, right? It cannot be 0 initially. So that's why guys, the flexure stiffness will get changed and it will reduce basically. Initially, let us suppose we are having certain value of K, but after removing it, after removing such type of support, the value of stiffness is equal to 0. That's why B is the correct answer. Very good, Rajesh. Very good. So I hope all of you are able to understand the question which we have discussed today. So these are the problem guys which I want to discuss with you, and I hope all of you are able to understand the question very well. Okay. So any doubt, any query if you have guys, please let me know. And what you can do guys, tomorrow we have again one more session in which we will discuss the force method problem, and in which we will discuss about the ILD and etc. portion, right? ILD, strain energy method and etc. right? So you can watch that particular video also guys at 5 PM on BYJU'S Exam Prep YouTube channel, right? Okay. So that's it for today guys, and if you have any doubt, any query, you can ask me anything. But I'm closing the session right now guys. If you have any query, any doubt, please let me know. Okay, and I'm sharing a Telegram link over here, guys, which you can join easily, and ultimately you will get this particular PDF. Okay. Okay, guys. So let's close the session and let's meet in the next session, which is tomorrow. Okay. Bye, guys. Take care. Thank you so much for joining the session.